Hello, dear students. Today we have Proposition 35, Book 1, Proposition 35. Parallelograms on the same base and in the same parallels are equal to one another. Here we have two parallelograms. It's given that they're on the same base and that they're in the same parallels. Thus, it is required to prove that this parallelogram is equal to this parallelogram. Let us connect the two lines. Okay, so this and this are parallel to each other. Thus, okay, let's start having some fun. Let's see. We know that this is equal to this side is equal to this side, because we know from our bag of knowledge that in parallelogramic figures, the opposite sides are equal to one another, okay? By the way, we're also going to use this proposition showing that lines which are parallel and have a line falling upon them, the external angle is equal to the opposite angle on the same side, opposite interior angle on the same side. We're going to use side angle side. You remember with the two triangles, side angle side, equals added to equals, the wholes are equal. Okay? So here we have this equals this, because this is a parallelogram, and this will equal this, because this is a parallelogram. All right, let's now show that as this and this are both equal to this, they're equal to each other. Two things equal to the same thing are equal to each other. So let's add this to this and to this. So we're going to add this line to both this line and this line. Equals added to equals, the wholes are equal. So this will equal this, okay? And we know that in this parallelogram, this line equals this line, okay? Now we just need to show, we can use side angle side if we have this equal this. That is so because we have two straight lines with a straight line falling upon them. The external angle will equal the opposite and interior angle. Let's just use a blue one here. This angle will equal this angle, okay? So now we have two triangles. Okay, see that? This triangle and this triangle, such that two sides are equal to two sides respectively, and the angle the two sides contain are equal. Therefore, the base will be equal to the base, we know that, and the triangle will be equal to the triangle. So this whole triangle is equal to this whole triangle. But look how this is common in the two triangles. Look at this triangle and this triangle, which are equal, and that this section, this chunk, is common. So let's sack out, let's take away this chunk, and the remainders are equal. Equals, taken away from equals, the remainders are equal. So this parallelogramic figure now is equal to this parallelogramic figure, okay? Now let's add this to both sides. So we have this being equal to this, we've shown that. Let's add this to both sides. Therefore the whole will be equal to the whole, okay? Equals added to equals are equal. But this is our parallelogram, and this is our other parallelogram. We've shown that now that they're equal. So we've seen then that parallelograms on the same base and in the same parallels are equal to each other. Quod erat demonstrandum. Thank you. Bye-bye.